All right, so having briefly dived back into pre-calculus in part C of this question, 7D asks us to go back into calculus material and determine the intervals on which the function is increasing or decreasing, and to classify any relative or local extrema. And it helps here that we've already been given the first derivative because all of this hinges on that first derivative. The first thing we need to do is we need to find any critical points of this function. And there are two ways that we can get critical points. One way would be if this derivative is undefined, but the only way 4 times 3 minus x over x plus 1 all cubed will be undefined, because it's rational, would be if its denominator is equal to 0. That only happens at x equals -1, and we already know that that's the vertical asymptote in the graph of the function. It's not in the domain of f of x. So we're not going to get any critical points that way, because to be a critical point, a value of x has to be an actual point on the graph of the function. It has to lie in its domain. We'll first note that f prime of x is undefined only at x equals -1, the vertical asymptote. So instead, we're just going to set that first derivative equal to 0. And much like when we talked about the x-intercepts in part C, setting a fraction equal to 0 really just means setting its numerator equal to 0. So then we've got 4 times 3 minus x equal to 0, which means x must be equal to 3. So that's the only critical point in the graph of this function. We're going to use that now to figure out where the function is increasing and decreasing. So we're going to sketch a little sign pattern. And this is going to tell us how the function behaves based on the behavior of the first derivative. And we're going to mark off 2 points. We're going to mark off the vertical asymptote. And to remind ourselves that that can't possibly be a relative maximum or a relative minimum or even a saddle point, we'll put a little VA on top there, just to remind us that is the vertical asymptote. But then we also mark off our critical point at x equals 3. And so what this does is it splits the domain of the function up into 1, 2, 3 intervals. But on each of these intervals, the function is either strictly increasing or strictly decreasing, because the first derivative is either strictly positive or strictly negative, and that connection is given to us by the first derivative test. So all we've got to do is pick a value of x in each of these intervals, plug it back into the first derivative, and that will tell us everything we need to about the function. So first of all, for x less than -1, we might think, say, x equals -2. Well, again, we don't actually need the value of the derivative at -2. We only need to know whether it's positive or negative. Having the derivative in a factored form helps there. So if x is -2, well, our numerator is going to be 4 times 5, so positive number times a positive number is positive, divided by -2 plus 1 would be -1. Cubing that is still a negative number, so we've got a positive number divided by a negative number. That's a negative number. Then, in our second interval, between -1 and 3, take, say, x equals 0. Substituting that into the first derivative, we'd get 4 times 3, which is still positive, divided by positive 1 cubed, which is also positive. Everything is positive, so the first derivative is positive. And then for x bigger than 3, say x equals 4, we've got 4 times -1. Now that's a negative number, divided by 5 cubed, which is a positive number. Negative divided by positive, it's back to being negative again. So the function is decreasing, then increasing, and then decreasing again. So from that we can say that f of x is increasing for x bigger than -1, less than 3, And of course, you could write this in interval notation too if you prefer. Doesn't matter. It's decreasing for all x less than -1 and for all x bigger than 3. And finally, that single critical point we've got at x equals 3, because the function is increasing to the right and then increasing to the left and then decreasing to the right, that's a relative or local maximum. And we want the coordinates, the x and y coordinates of any key points, because in part f we're going to put this into our graph, and we don't have x equals 3 as a point that we've identified yet. So we go back to our function, we put in x equals 3. We'll get 4 times 3 is 12, 12 times 6 is 70, divided by 3 plus 1, that's 4 squared. So let's see, that's 70 over 16, which is going to be the same thing as 18 divided by 4, which is 9 over 2. So this is the point 3, 9 over 2. And there we go. There's everything that we can obtain from the first derivative. We know where the function's increasing and decreasing, and we've categorized that only critical point as a relative maximum. In part E, we'll see what the second derivative can do for us.